So I built this custom relay module, not realizing that the relay I have does not allow switching enough current. It only is rated for about a half an amp, and I want to be able to do a lot more than that. So I'm going to rebuild a new one of these, but with a much larger relay. So I thought it'd be kind of fun and a neat experience to try and do it all by video and kind of walk through what I'm doing. Who knows how this is going to turn out. I may end up looking stupid. I have a GoPro attached via some Gorilla, I think they're called GorillaPod arms, to my light. So anytime I bump the table, the video is going to move. That kind of sucks, but I need to get some kind of tripod set up. So anyways, here we go. The first thing I need to do is have a way to trigger the relay. So real quick, I set up some code on a Raspberry Pi. It's connected through a cobbler onto a breadboard, and I have Blink code loaded onto it, just a really simple Blink code written in Python. So just to show what that does, let me connect this. So pin here, and then resistor to ground, and then I'm SSH'd into the Pi, so if I run the program, it starts blinking. Just so you get an idea, I'll just feed that signal in to the relay module then. So I can set that aside for now. And we're going to get a breadboard, the relay. This thing does not fit into a breadboard, so what I'm going to do is use some alligator clips to clip to the leads on here, and then I can plug those into the breadboard. Let me bring up my schematic on the computer. Let's see here. These are the pins for the coil. Or sorry, for my signal. And then this will be the power source, which you want to switch on and off. They should be normally open and normally closed. I'm not sure which one is which. Didn't really take a good look at any schematics on this particular relay, but usually they're all pretty much the same. So I'll just plug this in over to power. Let's see here. Gonna use a little transistor. This one is a PN2222A. I believe this one goes emitter, base, and I can't remember what the C stands for. So I'll use this rail for the power that I want to switch, and I'll use this rail for the power and ground of the signal source, which will be the Raspberry Pi. the emitter goes to ground. And then I also need some resistors. $10K. And a $1K. Let me put this over here. I need this pin to be grounded through the resistor. It's just a pull down resistor basically. And then this resistor, the 1K resistor, will go to the signal which will come from the Pi. We use this is a 41 and IN or 1N4148 diode. So this is going to go from the third pin on the transistor and that'll feed in to that pin on the relay. That pin on the transistor also can go over here in the relay. And we also need power, Pi. Go over to here. That's all there really is to it. If I get that connected right. So what I'm going to do here is connect this LED to one of these output pins on the relay. I'm not sure if it's normally open or normally closed, but we should find out really fast. That's where the power will come from, and then this resistor. Nope, wrong way. I need to ground it over here to the power source ground. What I'll use for my power source here is just a 9-volt battery. It's always good to test with lower voltage before testing with mains power. And as you can see, that's the normally open. If we go over here, this should be the normally closed, which is really what I'm going to end up using in my circuit, but just for demonstration purposes, so that you can see that this is not turned on. And there we go. So if I bring the Pi back out, signal here. I want to connect to that resistor. And then I need a 5-volt for the power of the signal. It's a 5-volt relay, and the ground to ground. So now if I run the blink code again, it should trigger the transistor, which will flip the relay when the blink code would blink, and then this should effectively blink, but now we're going the long way through. And there you go. You can hear the relay switch too. If I were to stop that, and it'll basically work the same way over here. If I connect this to the normally open, it's just that when the blink code will start, it'll already be on. As you can see, I start the code again, and it goes off. So sweet, the relay works. Now, stop that. I'm going to switch this back over here. Actually, no, I don't want this anymore. So now that I've tested with 9 volts, I can try it out with mains power just to make sure that it's working, which I already have kind of sort of wired up here. The ground, the negative is what they call, I guess, in electricity terms, and then our hot wire is the black. So let me connect a couple of these buggers here. Basically, we want this connected to this normally closed terminal block. Doesn't have to be perfect here, just so that it gets a connection that works. And then, let's see here. There's another one of these. Essentially brings in power from the plug, and instead of putting that on the breadboard, I'm going to get out another alligator clip just to make it easy to plug into this power rail over here. Now, plug this in. This is always a little bit scary. Everywhere online always has big warnings. If you don't know what you're doing, you're at all worried, definitely do not mess around with switching mains power. Consult an electrician or a professional. I am definitely not a professional. So here goes. Power. A little tester here will light up when I supply juice to the outlet, which I just need to turn my blink code back on. As you can see, it's working. The two orange, which correspond to two yellows, mean the wiring is correct. So I'm switching power, mains power on and off through this circuit by a little signal from the Raspberry Pi. So I know that the circuit works and the relay is wired up as kind of expected. So I'll take a little break and then I'll come back and get this all soldered up on a circuit board. See you soon. Okay, so I have a bit of a failure here. After doing the breadboarding, I was planning to record all of the building of the circuit on a circuit board, and actually I did record. I have well over an hour's worth of footage, but I made a bunch of mistakes and it didn't work. So let me just talk real quick about that. So here is the original board I did with the small relay that would not support enough current. So I needed to use the bigger relay. This is the next board, which was a transfer from the breadboard. So I got the relay in and the terminal blocks, a bunch of these little components, and then I started wiring in the terminal blocks to like the normally open, normally closed pins of the relay. And I did it once. I think I started off with these small wires, and then looking at my diagrams I realized, oh, I did this backwards. Well, not backwards, but wrong, where those wires should have been connected over here basically. So then I got that all set up and I was continuing on, and I kept looking back thinking, no, I had it right the first time. So I desoldered things again, removed the wires, put these back to the small spots. Okay, then I moved on to connecting in the terminal blocks over here, connecting the wires in, wiring what remained over to the transistor. Got it all set up, plugged in the Raspberry Pi for the test case, and plugged in the wire from the plug into the outlet. Fail. Didn't work. Looked more closely at the schematic again, and the small wires were not correct. So when I originally thought I had incorrect and wired up over to here, which would have been the second time, I guess, that should have been the correct wiring. But at that point, it was after midnight already, and I was pissed and didn't feel like troubleshooting, so I stopped the video. But that really doesn't usually cut it with me, so I was pissed, and well, that's when I figured out that I had it right the second time, and it was just those two wires that were wrong. But I didn't feel like trying to get this all done and desolder things, because then I would have to move this wire over to here, and I would have to get the other wire coming in over on this side for the signal, and that was just gonna be a big mess. So I set out to challenge myself to see how compact I can make the circuit. Oh, another thing that happened that delayed everything and made everything take a lot longer was the battery on the GoPro died just before I soldered in this last wire for the 5-volt connection coming from the signal source. So I had to plug in the GoPro, do some battery recharging, and wait before I even got to the point where I could get that last failure of this whole circuit done and test. So, long story short, that took a long time, and it didn't work. So then I made the challenge to myself to see, okay, I'm going to get this working and see how small I can get it. I wanted to come out of this and win. And usually, especially if I'm coding something and I lose all my code, the last attempt I end up realizing all the errors and all the improvements I could have made, and it always ends up being my best effort. So that's what I did. And as you can see, it's a lot smaller, and this one works. I cut it off already to save space. So here's the original. This one works, but the relay isn't large enough to support large loads or large currents, however you want to say it, I guess. This would have ended up being pretty much exactly the same size, even with the bigger relay. Helps that I removed the LED part of the circuit, and then as you can see, the final outcome is, let's see, 1, 2, 3, 4, 5, about 6 rows of holes smaller. So the next thing, now I just need to get this all fit in here, and then it's all set. So I won't take a video of that, but I will come back into a short little segment to show what it looks like in here and do a quick demo of it working. Okay, so just a really quick shot here to show the insides before I screw it all together. I cut 3 wires, 5-volt ground, and my input signal. Used a little bit of electrical tape on this side, clamped it in here. Used a little bit of electric tape here as well. Hopefully that'll help some from getting those wires pulled out. Everything's connected to this terminals here. I hot glued the, everything's connected to the terminals. I guess I wasn't in the video or under the camera. Hot glued the board to the side of the outlet box. Got the wires connected up to the outlet. It's going to be maybe a tight squeeze. I might hit on here a little bit with this, but that's not that big a deal. I don't need this to be completely sealed. So I'm going to finish closing this up, and then I'll give it a test. Okay, so I've made a slight adjustment after I screwed this all in and put the cover on. It was touching there, and there was still a little bit of gap over on the side, so when you would push in, it would put pressure on the relay, and I don't want that to end up snapping off some of the solder joints, and then the whole system fails. So I got these little metal strips off this original outlet metal box that I was going to use, and they fit perfectly. So now there's even a little bit of a gap in between the relay and the back of the switch, and there's no room to play there. So much better. Quick little update. Let me screw this plate on. By the way, these little screwdrivers you get with Nest thermostats, really handy. I keep one here at my hobby desk, another in a drawer somewhere. Alright, so that's all set. There's some movement there. Maybe I'll glue that down to it, but not a big deal. Plug in the tester. Already have this wired up to the Raspberry Pi, which is turned on and ready and waiting. Oh, let me plug in power. no lights on, and I'll start up the blink code on the Raspberry Pi, and as you can see, it's triggering the relay on and off. And just to show, both plugs work the same way. So there you have it. I have my very own little switchable outlet that I can control with Raspberry Pi or a microcontroller. Would have to be a microcontroller that lets you supply 5-volt power. But yeah, Raspberry Pi works great.